Hey y'all. So I'm back again. I don't know how I feel about these glasses. I just got them. I think they're honestly, I feel like they're a little too, the bridge is a little too tight. I might see if I can bend them a little bit. Run it under hot water first. I like that they're rainbow, of course, but what are these? These are 52, 16, 142. This is 53, 17, 145. So you would think maybe the those are just less comfortable. Whatever. Okay, so we're gonna pick up where we left off. Not yet doing the arm stuff because that's where we're at. Hopefully get to the arm stuff later on tonight. But yeah, let's go. Terminal. Okay, cool. What? Huh. Okay, so interesting. Okay, so this looks weird. So let's go take a look at our Docker file. Our demo Docker file, that is. Okay, so think I don't think we need teeny. Yeah. Oh, I do want dask map extensions. For sure. Okay. Let's go ahead. See about this. Make more flex for now. We'll target specific build closer to release. I guess Docker build dot dash f demo Docker file dash t test. Let's see if this builds. Yeah, okay, that'll take a while, but that's okay. While we're doing that, let's go back to okay. Yeah. Okay, sure. In the next chapter, we'll okay. Oh, fuck. Okay. Sorry. My brain. Time to set up a ray cluster. To set up illustrate with cluster or cloud. to connect ray to connect your ray install to 1. Okay, that's pretty okay. Workflow hello world, yeah, we'll get to that later for sure. Take a look at Grammarly all the way. Yeah, okay, fine. Okay, yeah. It is simpler to get started with a local installation. So in the interest of getting your local environment set up, and you log losing interest, right in, that is where we'll start. We will start. That is, we'll start there. Oh, fair. Yeah, because we do talk about calling a lot in the context of calling functions, so yeah. Oh God, I hate English names. We'll actually just get rid of the quotes. Oh, is it Sleepy Hello World? As well as some of the many ways to do word count and array. Also use gitpod on the example repo to get a web environment. Oh man, oh, pretty big contact. Oh yeah, that's why. Okay. There is a lot of shit in here then. Yee, 23 gigs. Fuck that shit. I guess what we'll do is mkdir web demo n git nv demo docker file web demo m. Okay. Other thing that we're going to do. And then it's also going to be web demo m. Update the references. That should, at the very least, build a little faster. Okay, let's go take a look at our demo Docker file. Okay, yeah, there we go. Oh, shit. Nope. Okay. Cool. Okay. So hopefully be a little bit faster. We will see. So, how are we doing? Okay, chapter 1, pretty solid. The thing that we're still missing, okay. Yeah. Okay. Now that you have Ray installed, we can leave off on your machine. It's time to learn about another we'll dive into each of these APIs in more detail later in the book, so don't get too hung up on the details for now. Solid, actually. Use fewer non... yeah, okay. We'll cover these APIs in more detail later. In the book seems superfluous, so don't get too hung up on the details for now. Okay, that's okay. That is definitely, no, that's source code. That's also source code. Has a specific meaning. Also has a specific meaning. Also. Won't log, waiting for the result. And result, but rather okay. Ray won't block waiting for a result when you call her. Okay. Rather okay. Let's rephrase this actually. When you call a remote function, Ray will immediately return a future. Return a future instead of blocking, waiting for the result. Well, Ray will return will immediately return a future when you call a remote function instead of blocking waiting for the result. Sure. Leapy task hello world. Sure. Normally, well, artificial, an easy way to see this. An easy way to understand how remote futures can help is by making an intentionally slow compute in sequence a regular function calls compute and remote calls. Okay. Launching, okay, yeah. Launching more tasks inside of other tasks can make certain kinds of recursive algorithms easier to implement. Okay. This web crawler. Story checks, I guess. In the web crawler, yeah. Oh, okay, cool. Needs, okay. Inconvenient. Because I really don't want to send the full context to it right now. And I don't actually know how to specify. Okay. Okay, yeah. Gitpod YML worker. Okay. Well, nah. For now, I'm gonna just hack this. Okay, yeah. But in practice, we won't actually build there, but I have got like a whole bunch of things. Oh, interesting. No shit, yeah? Hmm. Hmm. Ah. Hmm. Huh. I guess that's not. Hmm. Huh. Okay. Let's see. Maybe it's Python 3.7. That's fine. Jupyter Data Science Notebook. Yeah, like. Docker stacks. Come on. Yes, yes, yes. Yes. Mhm. Hmm. It's in their wiki. Don't. Data Science Notebook. I don't think I want Python 3.9. Hey, bud. Uh, yeah, that really just, I don't have any understanding of how to read this thing. Like, it just makes no sense to me. Maybe build manifest will tell me what's going on. Oh, that's 3.9. I don't want 3.9. I want 3.8. Can I get 3.8? Okay, Jupyter Data Science Notebook Python 3.8. Oh, cool. I can just say 3.8.4 left push. Okay. Python dash 3 dot. Hey, bud. 3.8.8. Okay, works for me. Hey, bud. No. I love you, bud. Okay. Hey, bud. What you up to? I love you, little bud. You do. Well, you're my big species right now. That's sick. Okay, well, whatever. That'll take a hot minute. We'll see how that goes. That's probably fine. Huh. Oh, that didn't work. Okay, that's fine. What was the next thing I was doing? I don't remember. Let's go back to things that I want to fix. Oh, yeah. Okay. That either... Yeah. Launch on a central coordinator node, or if they allow tasks to launch in a nested fashion, yeah, they still depend on essentials. Require that even those that allow tasks, even those that support launching tasks in a nested fashion, still normally depend on a centralized. Yeah, okay. Oh, yeah. So we have not done the data example. That is the one that I need to do. I think, right? Yeah, okay. Makes sense. Okay. To do, hold in. Okay, so that's what we'll do. Okay. I think that's what I need to do next. All right, let's go double check our Ray Chapter 2 examples. Yeah. Let's go kernel, restart, and run all. Okay, I'll take a minute. While it's running, keep going. If you're interested in that, check out Hold the Book. One of the other actors, practice state, which is one reactors are created. Similarly to remote functions, but inside a class for state. In action by modifying the classic Hello World example to greet you in you along with the time, along with the number of caller. Yeah. So, for the most part, there are for the most part, you can run the examples we picked for in local mode, albeit sometimes a little slower or at a smaller scale. Consider taking this time. Yeah. Okay. If you have access to cloud account or cluster, now would be a good time to jump over to doot. Okay, there we go. In this chapter, you have installed Ray on your local machine, and experienced and seen and used many of its core APIs. For the most part, you can continue to run the examples we've put for this book in local mode. Sometimes, naturally, local mode can limit your scale, and naturally, or make or take longer to run. Especially for the next chapter, we'll look at some of the core. We'll look at some of the core concepts behind Ray. Yeah. Yeah. In the next chapter. One of the concepts, fault tolerance, will be easier to illustrate with a cluster or cloud. So, okay, cool. Okay, we're gonna reload this because I wanna actually have Grammarly reprocess it. Okay. Okay. Cool. An excellent time to jump over to some different deployment options. Naturally, a local mode can limit your scale. In the next chapter, in this chapter, you have installed local, to a cloud account or a cluster. Okay. Good. Okay, let's go find may add. That being said, arm, yeah. Okay. It is likely that future versions, as ARM grows in popularity, Ray is more likely to add ARM wheels. So this is hopefully temporary. Okay, I want to Ray's data API is powered by Apache Arrow. Is powered by Apache Arrow. Yeah, this is kind of long. Apache Arrow. Arrow allows Arrow is a combination data format and data format. Arrow is a data format with some common operations. It allows it. Arrow is a data frame-like format with some common, no, not joint, popular operations. It also raise data, Apache Arrow powers raise data API. Yeah, sure. It's a data frame-like format. No. It allows. Yeah, okay, fair. Easy transfer. It is used by many tools and allows for easy transfer between them, like Spark, Ray, dask, TensorFlow, etc. By many popular tools. It is used. Fine. Many popular tools support Arrow. Allowing for okay. Yeah. All right, cool. Okay. Writing raw tasks for data manipulation is tiresome. Okay. Dude, Ray has a dataset API for working with data frame-like things. This saves you from the tiresome task of writing raw tasks or of writing raw tasks and reasoning about yeah. Okay, let's see what happens with structured data. Structured? No. Dataset API saves you from the tiresome task from writing raw, writing tasks, reasoning about shuffles, and reasoning about cross partition writing. Okay. Do Ray has a dataset API for working with structured data. Ray has a dataset API for working with structured data. That's just the same fucking sentence. Okay. Sometimes Grammarly. Not the best. Okay, cool. Let's go ahead, rerun it, see what happens. I don't think it's counting up anymore. All right, whatever. So that's reloaded. I guess the next thing we need to do, not dask. Dask one's a little bit further along. The Ray one. Okay, so now, what we need to do is, I guess, make the Ray example. Okay, let's make the Ray data example like the trivial one. But so here is the question: can I make so, okay, let's make a data set. So let's go ahead, create a data set of URLs. We could also load this text file with Ray data. Oh, that's not a thing. What can I do? What are my functions available? Like, I kind of want to just take a distributed list and make I don't quite want to do range. But like, maybe that's what I need to do. From items. There we go. And it defaults to a parallelism of 200, ostensibly. What are the ones that we used in the dask book? Because, hey, I'm lazy. URLs, DS. Oh, yeah. Let's swap that one for Ray. Ray-project/Ray. Yeah. Cool. So then what we'll do is we'll go ds.map. And let's see what I can do. Can I make this? I think I have a theory. Yeah. Fuck. This is gonna suck, isn't it? Because, like, I'm pretty sure I can't. Yeah. Okay. Like, fuck. I guess what I'll do is we will write fetch page vs fetch page Girl. Yeet. Return f.text. Do I have to? Don't. Fascinating. Okay, so that is something to call out. Oh, hey, Professor. Ray has a limited data set API for working with structured data. It's used dask on top of array. Okay. Actually, let's find out what Apache Arrow describes itself as. Apache Arrow, how do you describe yourself? Is a column-oriented, language-independent format with some popular Hey little bud, what you up to? Let's see. Did I start my timer? Oh yeah, I got a minute left. Okay. Yeah. Raise. Unlike the rest of Ray, the dataset API is eagerly evaluated. This means that when you call a function on a dataset, on a array dataset, it will block and compute. It will wait until it completes the results instead of returning a future. So what we'll do, another option, Ray's dataset API is relatively limited. If you want a more full-featured data frame API, you can convert your array dataset into dask. This is the recommended approach for complex operations. If you are interested in learning more about dask, you should check out Holden's book, Scaling Python Dask. Full-featured. Ray uses eager evaluation for its dataset API. This is different. The rest of Ray this is futures. Eager evaluation. Okay. Yeah. That's fair, I think. Huh. What? I don't particularly want to update conda. Container cannot be mapped. Container ID cannot be mapped to a host. Do not know what that means. I wonder if this just means I'm taking too long. Okay, so what could we do? Fudgesicle. Like, is it just that we're taking too long? Because, like, I could see that. Well, it's like, it's taking a long time. We don't have to run apt-get update again. It's not going to speed it up a lot, but it might a little bit. All right, let's give it a shot. Maybe taking too long. Let's give it another shot. Okay. That's cool. For values of cool, which are flexible. What are we going to do? Go back here. Yeah, okay. So that's all good for values of all good, which are flex. I don't remember what I'm doing though. Oh yeah. Okay, Ray data example, which is kind of like meh. But whatevs. Okay. Cool. Pages. We'll call this URLs. We'll call that pages. Fuck no. What can I do on pages? Dir pages. Do I? No. Okay. Do I have flat map? Hells yeah. What have I got on words? Please tell me I've got something. Got count. There is a reduce, but that's an underscore reduce. So I'm feeling like that's not what they want. Yeah. Reduce. Some take iter rows, limit map batches. Can I actually do a shuffle? Great question. This flexibility is a unique characteristic of array data sets. Yeah, that's bullshit. Like, yeah, I can pass a data set over the wire. That's not. Yeah, okay, I can't do that in Spark. But I can definitely do that in dask. Well, even I can sort of do it in Spark to a limited degree. Actually, maybe it's not bullshit. Okay. Well, whatever. Let's go take a look at the Ray data set. Okay, yeah. Has a very limited note. Yeah. Since Ray has such a limited dataset API, we cannot do the standard word count example found in word count example where we count word count example. We can Ray supports operations which do not require deterministic, which do not require Ray does not support any forms of aggregations on data sets. This precludes the most popular word count example. The most popular distributed data example is word count, which requires aggregates. Instead, we can perform embarrassingly parallel tasks like pure map transformations, as shown by constructing a data set of the words found on of web pages. Basic. Yes, hello. Oof. Construct data set of web pages. Okay. That's okay. Yep. Simplifies my life. Okay. Kernel restart and clear output. Hells yeah. Okay. Yeah. Damn. Okay. Well, c'est la vie. C'est la vie. NV /downloads ray-ch2 Wait, what? I thought I did restart and clear all. No. Kernel, restart and clear output. No. There we go. All right. Add ray example. Add ray Data set hello world example. Cool. Sounds good. Let's see how we're doing with our gitpod. Okay. Cool. Well, it's been about a little bit over an hour. I'm gonna go do stuff. Stop walking on my treadmill for one thing. But also, I think make dinner. Probably. Yeah. I think that's my plan. Woof. Hey. Yeah. Oh. Yeah. Cool. Thanks, everyone. Sorry. Yeah. My brain is a little shot, which is 100% okay. It's been a long day, but we made some progress, right? We went through the feedback on chapter 2, and for Ray, and we wrote the last example that was missing for chapter 2. Workflow is still TBD, but that depends on the workflow, library existing. With the number. And we got sort of the starting point of making a quick start environment for people that want to get started with Ray using gitpod and maybe codespaces. It didn't like actually like work, mind you, but it did make some progress, right? We got at least the container builds locally and some other stuff. And yeah. I'm also leaving myself a quick note about a piece of the wording that I want to improve for tomorrow. Cool. Anyways, yeah, so we're gonna wrap up. I'm gonna take this crap downstairs, gonna go make dinner. I hope you all have a lovely Saturday night. And yeah, it's been fun hanging out. Sorry my brain is so shot. I'm hoping tomorrow can make a little bit of progress on the dask book. Because at least for the dask book, I think we're up to like chapter 3, maybe. Yeah. Thanks, y'all. Fuck.